Okay, so let's talk about the law of large numbers. Now, the law of large numbers has an intuitive feel. That is, it seems to be common sense. However, the law of large numbers is often confused with a non-existing law called the law of averages. So, for example, consider a baseball announcer who says, "This player is due for a hit because he's gone several at-bats without getting a hit." Or consider a mother of 4 girls who says, "Oh, I'm due for a boy on my next trial." In both instances, there's confusion between the law of large numbers and what happens on the next trial of a particular probability experiment. So for example, if you have 4 girls, are you more likely on the 5th child to have a boy? Of course not. The likelihood of having a boy is the same on the first trial, second trial, up through the 5th trial. Another way to think of this, the biology of having children does not look at somebody and say, "Oh, you've had 4 girls, now it's time for you to have a boy." In other words, these trials, these random processes, have what's called a memoryless property. Trials do not recall what has happened in the past and use those trials to make changes in what's going to happen in the future. Now, to help see that, we're going to use StatCrunch to simulate having 5 children 10,000 different times. So what I'm going to do is I'm going to go to Data, and then I'm going to select Simulate, and then go to Bernoulli. Okay, now the number of rows I'm going to end up entering is, we're going to generate 10,000 rows and 5 columns of data. Okay, and then the parameter is going to be 0.5. Okay, now basically what this means is that each column is going to be representing a child. Each row is going to represent a family. Now we set the probability of success at 0.5 because there's a 50% chance of having a girl and a 50% chance of having a boy. Now I'm going to go click Compute, and all our children are born. Okay, so in this family, okay, what we're going to do is, in the first row, you'll notice that I have 3 zeros and 2 ones. So let's go ahead and say that zeros are going to represent a boy and 1 is going to represent a girl. So in this family, we have 3 boys and 2 girls. Now, as another example, okay, let's take a look at row 2. Now, in row 2, we see that we have all boys in row 2 since they're all zeros. So we have boy, 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 boy. Okay, now in our analysis, we're only going to consider families where the first 4 children were girls. How can we identify them? And what I'm going to do is now go to Stat, and then I'm going to go to Summary Stats, and then I'm going to go to Rows. Okay, and I'm going to select the first 4 columns. Okay, because the first 4 columns represents the first 4 children. Okay, and now I'm going to find where the sum of the first 4 children, and then store this data in a table. So I'm going to go down here, okay, and then I'm going to select Sum, and I'm going to store the data into the table. So I'm going to go ahead and compute. Now you can see here it creates another column called Row Sum. And so now I'm going to title this column Girls. And so we can see now that my first family had 2 girls, and my second family had 0 girls. Now, you can see here that 2 girls were in the 3rd family, 1 was in the 4th family, and 1 was in the 5th family, and so on. Okay, now, what we're going to, and again, okay, we're only concerned with those families where there are 4 girls on the first 4 children. So what we're then going to have to do is, among those families, we want to compute the proportion of times the 5th child was a boy and compute the proportion of times the fifth child was a girl. So how are we going to do that? So I'm going to select stat, okay, and then I'm going to go to tables, and then I'm going to select frequency. Now what I want to do is I'm going to look at Bernoulli 5, and the reason is because that's my fifth child. I'm only going to look at Bernoulli 5 where girls equal 4. In other words, it's only to compute the proportions of the fifth child where I had 4 girls prior. I'm going to get a frequency and a relative frequency because I have frequency and relative frequency here. And so now let's click compute. So now when I click compute, okay, what we're going to notice here is, remember that 0 represents boys and 1 represents girls. Now if we notice the count, meaning out of 10,000, okay, where I had 4 girls on the first 4 children, we can see here that that percentage down here represents 50.2%. Now, if I look at where I got 0 for boys out of the 1,000, I got approximately 49.8%. So it is certainly not the case that I'm more likely to have a boy on my fifth child if my first 4 children were all girls. So, in this previous video, it is clear that just because my family has 4 girls, the family is not due to have a boy should they choose to have a fifth child. This illustrates that the law of average is not a law after all.